for now. All right, section 1.4 is solving linear equations. Okay. So let's talk about what a linear equation looks like. So solving linear equations in one variable. So let's define what a linear equation is. That's its equation. A linear equation in one variable. So we'll call the variable x. It could be any letter though, right? Could be y, could be z. Any letter for our variable. Is an equation of the form ax plus b equals 0, where a and b are real numbers and a does not equal 0. Okay, so let me read that again. A linear equation in one variable x is an equation of the form ax plus b equals 0, where a and b are real numbers and a does not equal 0. So I have one variable. What's the exponent on my variable? 1. One variable. The exponent is 1, means it's a linear equation. Graphically, what does a linear equation look like?
It'd be a line.
It's a line, linear line, right? So if I were to see a linear equation on a graph, it would be a line.
So no parabola, essentially.
Right.
Yeah.
X to the first power, one variable to the first power is line. Yep.
What does that word say right there? The F, the one with the F?
Form?
Form, yeah.
Okay, so let's solve some linear equations. Or let's do a little chart about how to solve. So how to solve. Okay. How to solve. So if I have x minus 3 equals 8, okay, that's a linear equation. I have x to the first power. I have one variable to the first power. That's linear. Okay. So now the goal of linear equations is to get x equals a number. Let's write that down. The goal is to get x equals a number when we're solving linear equations. Okay, so what's next to x here? So there's a 3 next to x, right? I'm subtracting. So Dakota says the opposite of subtraction is addition. Okay? So then I'm going to add 3 to both sides. And why am I adding? Because you're doing the opposite, because negative 3 plus 3 equals 0. And so on the left-hand side, all I have left is x. And then 8 plus 3 is 11. That's my answer. Right? So the operation between x and 3 is subtraction. The opposite of subtraction is addition. So I'm going to add 3 to both sides. And the reason I do that is because negative 3 plus 3 is 0. And then I'm just left with x on the left side. Whatever I do to one side of the equation, I have to do to the other. So if I add 3 to one side of the equals, I need to add 3 to the other side of the equals, right? Yes? Okay. So that's how to solve if I have addition, or if I have subtraction. Let's say I have x plus 4 equals 10. Okay, so the goal is to get x equals a number. I want to get x by itself, right? So I want x equals stuff. I want only x's on the left side, only numbers on the right side. So the opposite of addition is subtraction. So I'm going to subtract 4 from both sides. And the reason I do that is because 4 minus 4 equals 0. So on the left-hand side of the equals, I'm left with just x. On the right-hand side, I'm left with 6. Something else we're going to run into is multiplication. If I have 2x equals 4, what's the operation between 2 and x? Good. So it's multiplication. The opposite of multiplication is division. So I'm going to divide by 2 on both sides, because multiplying by 2, the opposite of multiplying by 2 is dividing by 2. And why do we do that?
Why do you do to one side, you do the other side?
No, why am I dividing by 2?
Cancel out the 2.
What do you mean cancel out?
So you only have x left.
Because 2 divided by 2 is 1, right? So that's fine. That's exactly what we want. We want 1x. So x equals 4 divided by 2, which equals 2. Okay, and then the last one, let's say I have x over 5 equals 2. What's the operation between x and 5? Division. So I'm going to multiply. The opposite of division is multiplication. So I'm going to multiply. And the reason I do that is because that again equals 1. So I have x equals 10. So we're basically doing the opposite operation, right? So next class, we're going to put all of these ideas together to have more complex problems.